Hello, welcome to the second part of making the cable tool. Now in this part, I want to add some smaller detail cables that will make the cables in overall way more interesting than they are right now. So if you followed along, we already created this setup. So we have a basic cable hanging. So from a certain input, which is our line here, we are creating a couple cables. So next up, the idea is that I want to wrap a smaller cable around these bigger cables. And in the simulation, that will actually really work super well and create a lot of detail for us automatically. So first of all, let's make some space. So after our main sweep here, I want to split this a bit up because we're going to create a new network over there. So here, as I mentioned, we want to have these main cables. We'll call also this, for example, main cable. We could, for example, do another sweep here. And in here, what we're going to do is, for example, put it on tube, set this to columns, and we're going to wrap around, like as you see here, other cables around this. So we could also, for example, go to the rotation and we can give this a little twisting and spinning. And this is sort of what I want to do. Now I want to actually do this in a loop because each loop I can actually add a bit more variation. So it's going to be the same idea, but this sweep node will be in one loop to actually generate more variation. So let's start within the actual system. So first, we can also do a random deletion node. This is a labs node tool, so make sure to install SideFX Labs. And with this node, we can say that maybe not every single cable I have here needs to have like smaller cables wrapped around itself. So when we change this to from points to primitives, and we can increase the ratio, we can then here, as you can see, select those cables. So if I put, for example, this on half, half the cables will not have these small cables. So we can say that maybe one can be deleted. So we can just say here, delete selected, and then these three will be used in the system. Now, furthermore, what is useful to do here is doing a resampling. This might be useful in case you need more points or detail or even less. So for now, I'm going to keep it as default. Maybe I come back to this and add some more resolution if I feel I would need it. And then we're going to create a loop. And the loop we're going to use is the for each number. So we're going to place it over here and we have this. So this loop is controlled by the iteration value you see here over here. So this loop will calculate 10 times. You could see here the number. We will calculate this 10 times because here it's filled in 10. So if I lower this, it's going to be, for example, 1 or 2. So this is how this loop works, is we can manually say how many times we need to go over a certain node network. So as I mentioned, what I want to do here is place a sweep node in here. And in this sweep node, let's, for example, maybe actually add a second input. We can do another circle here. So circle, add a circle. Now we have this input. And in this case, what if we just maybe set 1? So actually we have one single line here. Now if we go back to some of the rotation properties in the sweep node, we can start to, as you can see, like roll this around. So maybe we can use the twisting here. And this is something that is going to be quite interesting to use here. So maybe let's tweak this a bit more. So maybe we need to reduce the scale a bit, like so. And what I also can see is these are actually just points. They are not actually connected. So if we go to the surface type and set this to columns, we actually have just one line wrapped around that. That's exactly what I want. So now the reason why we can do this in a loop is now I can say how many times I want this. So right now it's going to be calculating 2 times. So in total, of course, I will have 6 primitives because we do this 2 times. So loop 1, we will have our 3 lines. And the second time I loop, we will add that second loop and we will have 6 lines in total. And right now they are exactly the same each loop. And that's why I actually have a loop, so I can randomize this each loop. So I can, for example, try to get these values of the iteration or the amount and use that, for example, here in the rotation. So in the rotation, I can say if this is loop number 1 or 2 or 5, make sure you are adding some more randomness in there. And there are a couple ways of doing that. What I personally would like to do is use here our metadata. So as you can see, we are gathering here some data. And in this data, we can get the iteration number. And this is basically what I'm going to do. So in this sweep node, I will here add a spare input. And this is all the way at the bottom. We have a spare input. We can drag our data in here. And as you can see, our nodes are actually now linked together. So this is also visually showing you that we want to do something with these two nodes together. Now, furthermore, what we can do here is to, for example, adding a random twist now. So how can we get this iteration number? This is stored in the detail attribute. So what I will do is I will say, look at the detail attributes and look for something that is called an iteration. So the first value to fill in here is to say -1. And -1 is referencing to the spare input. So whenever I type -1, this is referencing to our spare input. Then we need to say, what are we looking for, which is the iteration number. Just make sure you're typing this correctly. And then we say the index, which is just 0. So we need to have these 3 values. So after that is done, we should actually now, as you can see, have more randomness in there. So each loop we're actually outputting now a different cable, as you can see. Now further, we can play around with it more. A good idea is to actually say +1 because the starting value will be 0. Then we can copy paste this value and we can, for example, use it over here in the role. What we can also do is we can actually add a random function in front of it. So we can say get a random value from the loop iteration, and this will return a value between 0 and 1. So right now it's actually not visually doing too much. So because this is a degree number, we need to, for example, say multiply by 90 degrees. Now you can see it's a bit more random. We can also here fill in a random value. So I can copy paste this here in the twisting value as well. And you can do more and more things. For now, I'm just going to leave it like this. I'm pretty happy with the result that I have right now. And I want to try to now use this in my simulation. So if you're a bit more experienced with Houdini, you can add more randomizations for these cables. But for now, let's just leave it as it is. Next step is merging the two cables. So I'm going to merge my large cable or the main cable with the small cables. So here we have these smaller cables now wrapped around. Quite recommended doing is also making a group node here to say what is what. So here, this is the main cable. So main cable, and this is here the small cables or sub cables. Small cable. So later on, I will always be able to get the data after I do a simulation. After I do this whole simulation again, I can get the data back again. So now let's just double check if we are getting the correct points here. That seems correct. We are getting still a random value. We can do the configure and let's see what the simulation will give us by default now. And as you can see, by default now, we are getting some very interesting results. So this looks already pretty good. It looks quite interesting, but it is not perfect. So one thing that I would say bothers me is that the cables don't really have thickness. So you can see that they are quite close to overlapping. So if I would now give this geometry by sweeping, so sweep, adding this to a tube and setting the tube to radius 1. So you can see that it's not perfect. What I would also often do is actually use a clean node over here. So clean the data, because the simulation, as you can see, brings a lot of data with it. And I don't necessarily want to use all this data. So clean data, remove all attributes, but don't delete p-scale. So that's what I'm doing here. So delete everything except from the p-scale. And let's look at that. So as you can see right now, all the cables are quite similar in size. And I want to change that a bit. So even though this simulation looks already pretty interesting, I want to take this to the next step. And the way we are going to do this is we need to actually go back to our configuration. So again, if we want to configure something or set something, we need to set it in our configuration constraints. And all the way at the top here, we actually have the thickness. And if you visualize the thickness, this is our thickness of the cable. So each cable or line is this scale. So that's not realistically what is happening here with my simulation. So what we need to do is we need to set attributes, like for example, the p-scale attribute, and use that in that configuration. So I already set a p-scale value for the main cable here, which is here quite consistently around the value 1. And for here, for my smaller cables, I don't have any p-scale. So we're going to say create attribute. And we're going to create an attribute, of course, called p-scale. And I'm going to give this the value 0.5. You can make the smaller, bigger. It's up to you. Or you can even do random values. You can, for example, use use this in the loop and then do the same process before, like do a spare input and get random values. But for now, let's just say these are just smaller cables at 0.5. So we now actually have for each of them a p-scale value, and I'm going to use this now in the configuration over here. So the thickness now is calculated uniformly. So we're going to change this to calculate varying. And this gives us the ability to now set a scaling value by attribute. And as you know, you want to use that p-scale that we just created. So it's set p-scale, and now we have that here. So as you can see, it's still quite small, and that is because our global scale here is set to 0.25. So let's set this to, for example, 1. And you can see that we now have a variation there. So you could increase this to something a bit higher, but of course, the higher you go, the more intersecting we have, which is not always nice for the simulation. So let's just set this to 1 for now. So for example, to test out if the p-scaling is working, I can always come back here, set this to, for example, 0.2. And as you can see now, these are way more smaller. So I can go back here and maybe start to increase that like so. And let's go back to our simulation, hit reset, and it's going to recalculate, and now I have a new result. So now if I would go back to my results here, it actually should give a bit better result in terms of my scaling. So it's not perfect. As you can see, some of the cables are doing a little bit weird. So we want to fine tune a few things here and there yet. So for our first test simulation, let's just maybe set the scale to 1. And let's see what that result gives us. So we have our base result. Let's just play. And that's looking pretty interesting on what is happening. We can also here in our simulation itself, we can do some couple things, like we can set a type scale, which might be useful here. We can do increasing of the substeps. We can also here visualize the thickness. So geometry, visualize thickness. So you could see if it actually has been following the shape somewhat nicely. And let's see what we have. And I'm pretty happy with the results, what you see. So we have our main cables that are a bit thicker, and then we have these smaller cables going around it. So that looks pretty good. So I can do resimulate if I want. It should be the same here. And of course, the longer you go in your frames, the more things might look better, or it might even get rid of some details. As you can see, like in the beginning here, I had some of quite nice details going on over here. So it's also a bit about playing with the things you have. So I can always go back to our configuration node. Let's, for example, increase the stretch here. So this is the overall stretching. Maybe increase that a bit. Maybe just set the bend to maybe set the bend here to 0.1, which is actually the default value. And we can also go back here to this over here, and we can say like we want this a bit thicker. So let's increase the P scale value here. What we can also do is, this could work nicely if we could maybe do views here, which might actually attach a couple cables together. Might be interesting to do. And let's see how that works. So let's press play again. And then we have this result. So our cables are now a bit thicker. Looks pretty good. Quite interesting. So now it's going a bit back and forward between some of the values we have. Some of the things we might want to tweak. You can even add more resolution to the curves. As you can see, we are having like a lower resolution in the simulation to work with. But if we want to bring this in game, of course, we want to actually then reduce this back again. So that's the last thing we might want to do here is let's just make this a bit more game optimized, or try to optimize this a bit more. And what I would often like to do here is we could either do a resample again. Might be useful to do a resample again here, since we are stretching the cables actually a bit in the simulation. And in here we could also do, for example, subdivision. So we can actually smooth out the cables a bit more. And after that, we want to use the facet node. And in there, we actually have an option to reduce points based on how far they are bent, for example. So if we here remove inline points, and if I enable the point view, you can see that we are now deleting points based on how much is actually needed. So you can clearly see here that these are now deleted, which is quite interesting. So this is a quite low value to play around with. So keep it on the lower side. So if I increase this a bit more, you can see that I will reduce the points a lot. And now sweep this. And we will still have a pretty good result, but on a much lower poly count. So now we are around 5,000, 6,000 primitives, and before we had 15,000. And you can see that the result is quite minimum. So it doesn't impact the overall quality that much, even though we are reducing some of it. So there are more reducing options you can play around with. You can of course use the classic poly reducing method. We can also here split the lines. So we can actually here split based on main cable and sub cable and small cables. So we can, for example, that the main cable can, for example, have more topology. And then we can say that the small cables, for example, can have less topology. So we can make them like a triangle in the sweep node. And merging this together will even reduce it way more. And this is around now 3000. And without actually reducing this too much or reducing the quality too much, because this holds up pretty well if you put this in game engine. So that was it for this video. Next video, I'm going to talk about making the asset. And then later on, I want to bring that asset, of course, inside a game engine. Thank you for watching.